The other thing that's in this section is solving some problems involving squares and cubes. In grade 8, you did a little bit of this with perfect squares, right? So it would say, here's a square, and it has an area of 49. What's the length of the edge? And you were expected to recognize that you need to look for the square root of 49, and you found that it's 7, right, if it's a square. Right now, we're also including now perfect cubes. It says solution here, and it goes right to using prime factorization. There should be a little bit first for just setting up and understanding the problem, I think. When you're solving a problem such as this one, you got to read the thing first, maybe draw a picture, label it, identify some variables, all those kinds of things. That's what I would do first. If you're trying to solve this thing, it says they make this certain amount of uranium, this radioactive element that they produce in Saskatchewan. Maybe they have a lot of it there. They make about this. This is the amount of the volume that they produce. That's a pretty big volume, 512 cubic meters. If this volume were made into a single cube, what would be the dimensions of the cube? I would tend to, for something like this, if I was solving this, I would draw a quick little sketch of the thing. You don't have to, but it's a good idea too. Here's this cube. I would even give it the edge length, label the dimensions. If it's a cube, do I have to put length, width, and height on it? If it's a cube means all the dimensions are the same, so can I call them all X or S or something like that? S for side or X for, just because X is what people use. I would even write an equation here. I would write, we don't know what X is, but we know that X cubed, right? Or in other words, we were looking for the volume, right? Volume. We're not looking for the volume. We have the volume. But we know that X times X times X is 512. Or in other words, X cubed equals 512. So how do you find what X is? If X cubed is 512, we got to use the inverse operation to find what it is. Okay? You've used inverse operations over lots of years here, like in grade 8. If you have 1.7 times X equals 10.3, how do you solve for what X is? Well, you do the inverse of multiplying on both sides. You divide, right? I'm not trying to insult your intelligence here. I'm trying to remind you what you have because it cancels that out. We are going to do the inverse of cubing something. The inverse of cubing something is doing the cube root. If you actually want to write it this way, you can. You can write this. I'll write it again. If you're good at solving equations and doing the same thing to both sides, you want to watch this carefully. If I have X cubed as 512, what happens if I take the cube root of both sides? What happens on this side if I take the cube root of X cubed? What do you get? Cube root of X cubed? It's like square root of X squared. What do these two operations do to each other? Squaring something and then square rooting it, if they're inverses? What if I steal something from you and then give it back? Or take something from you. We won't use the word steal. If I take something from you and give it back, those are inverse thing operations, right? Take it and give it, those are inverses. The net result is at the end, where are you? You're back where you started, right? This is the same thing. If somebody squares this thing and then square roots the thing, what is it going to end up being? Isn't it just X? If I take the cube root of something cubed, what am I going to end up with? Just that X there. Okay? However you're going to approach this, whether you write this step or not, you should know that if X cubed is 512, X is the cube root of 512 in solving this problem. Now, it's at this point that you might want to try, if you really want to use prime factorization, you can. For a problem like this, I would expect that you would just figure it out using the calculator, because the problem is more the focus here. But if you want to, you can use prime factorization and break down 512. Whoops. 512, if you actually break it down, you'll find that it's 9 twos. There's a whole bunch of twos here. I think there's 9 twos. Prime factorization only works if it is a perfect cube, right? This you can make 3 equal groups. and the 3 equal groups work out to 8. So then that cube root has to be 8. That method only works if it's a perfect cube. I would put that note here. Works if it's a perfect cube. The second method works no matter what it is, right? Because if this was, let's say that this was like 256, and there was one of the 2's missing, you can't figure out the cube root if it isn't going to end up being a perfect cube. But this second method here that says use a calculator, just punch that in your calculator and you're going to get the 8. And then it works with anything. Like if the original number was 300, you could do cube root of 300, you're going to get some approximate number and it'll still work. Okay? Does that make sense to you? There's another similar question here, except for it talks about a square with an area. So you got to decide what you're doing, cube roots, square roots, dealing with cubes and squares. So what you guys need to do is go back and fill in the missing pieces on some of the examples. Remember, they're in the textbook. You can use that. And do these couple questions, and then get going on an assignment. Okay? That textbook assignment. You got lots of time to work with here. I would really like to keep you on pace for this unit. So for next time, really you need to finish up to the end of this section. Okay? That's kind of the nuts and bolts of it and where we have to be. All right? Can you get started on that?